Before we get started, questions on homework. One too many. No. No, that's me. I'm not charging you for that. So, what we're starting today is solving rational equations. Restrictions are going to come back with solving equations, because in stating the restrictions, especially for 7.51, isn't going to be a big piece of this puzzle. It doesn't really impact it a whole lot, but it is something good to note, because our restrictions are going to be any value of x that would make the denominator be 0. We cannot divide by 0. And when we find the restrictions and are looking for this here and start in solving, we need to make sure all the denominators are factored as far as possible. We can't simplify it. There's no greatest common factor. It's going to make things easier to work with. Now, x plus 1 is one of our denominators. Can't factor any further. So any value of x that would make this be 0 will be a restriction. Our other place that we can have a restriction is 4x plus 5. Because if a value of x made 4x plus 5 be 0, again, it would be a restriction. We cannot have those. So with our x plus 1, first thing we can do is subtract 1 from both sides, telling us that if x is equal to -1, that one denominator would be 0. We cannot have it. And we can do a similar thing with 4x plus 5. First thing we do is subtract 5 from both sides, telling us 4x is equal to -5. Divide both sides by 4. Telling us that if x is equal to -5/4, we'd have a denominator of 0. We cannot have that. So that does help us mainly figure out what x cannot be. And it's going to be really helpful if we solve this problem. We solve these problems, and one of the solutions is a restriction. We can throw it out. Because those values, if it comes up as a solution, if we get -1 as a solution, it is what we call an extraneous solution. It's a solution we get by solving, and it is correct in solving process, but it does not work in the original context. Questions on anything so far before we start solving? Now, one thing that would be very nice is not to have to solve with fractions. Because one of the main ways we can solve is that we get everything on the same side, get it set equal to 0, and then add or subtract the fractions to go from there. But if I can multiply both sides by something and get the denominators to simplify out, that will make this process a lot nicer. So say I multiply the left side of this equation by x plus 1. If we do that, because we're going to multiply, we're going to end up multiplying the whole thing through. We're not multiplying on top and bottom. This expression over here would be 3 times x plus 1. But if I do it to one side, we have to do it to the other. So we multiply the entire equation by x plus 1. On the left-hand side, we get 3 times x plus 1 on top. On the right side, we get 9 times x plus 1. Now we still have the denominators, x plus 1 and 4x plus 5. Questions on this so far? Now this is kind of nice because on the left-hand side, we now have x plus 1 over x plus 1. The x plus 1 and x plus 1 will cancel out. They will simplify out. Well, they also simplify on the right-hand side. Well, no, because on top we have x plus 1. On bottom we have 4x minus, or 4x plus 5. Those don't simplify. So that doesn't help us too much, but multiplying by the x plus 1 on the left-hand side did simplify, yes? So what else would we need to multiply by? 4x plus 5. Now, multiplying by 4x plus 5 on the left-hand side really doesn't do much for us. It doesn't simplify the fraction, but that's already been done for us. On the right-hand side, by multiplying by this 4x plus 5, we now have 4x plus 5 over 4x plus 5, and those would indeed cancel out. Do we have anything left on the bottom of the fraction? Well, no, everything's simplified by what we multiplied through, and what this leaves us with is 3 times 4x plus 5 is equal to 9 times x plus 1. And really what we did is we multiplied by this least common denominator so that the fractions in this equation simplify out, they reduce out completely. Questions on this here? Now we just need to solve for x. And the first thing we can do in solving for x is to distribute the 3. 3 times 4x is 12x. 3 times 5 is going to be plus 15. Equals. We'll do the same thing with the 9. We'll distribute the 9. 9 times x is 9x. 9 times 1 is 9. Now we need to get x by itself. So what can we do first? What do we do first to get x by itself? We can subtract 9 from both sides. 12x is still going to be 12x. 15 minus 9 is going to be plus 6. Here on the right-hand side, we still have 9x, but our positive 9 minus 9 would give us 0. So we're able to get the constant terms on one side. Now we need to get the variables on the other. Yes. Yes. You're welcome. So, to get the x's on the same side, we need to subtract 12x from both sides. Our 12x minus 12x would give us 0, leaving 6 on the left-hand side. And 9 minus 12x, 9 minus 12 would be negative 3x. Lastly, we would divide both sides by negative 3. Negative 3x divided by negative 3 would be x. And 6 divided by negative 3 would be negative 2. So telling us x is equal to negative 2. Questions on this here? Now, if we want to check and make sure, one thing we can do is go back and plug negative 2 in for x. And we want to simplify both sides of the equation and see, do we get the exact same expression or exact same number? If we do, then they are equal. So all we're doing is checking. Now, if we did this by hand, negative 2 plus 1 is negative 1. 3 divided by negative 1 is negative 3. On the right-hand side, 4 times negative 2 would be negative 8. Negative 8 plus 5 is negative 3. And 9 divided by negative 3 is negative 3. Telling us that both sides are indeed negative 3, so that is the correct answer. We also know it because it was not one of our restrictions. Questions on this here? I think y'all have also learned something called cross multiplying, being able to multiply across. So here, and we talked about it, and you've done it before, cross multiplying is we multiply these two and set it equal to the product of these two and solve for x. Well, what we ended up multiplying was 3 times 4x plus 5 and 9 times x plus 1. So what we did and the way we solved this was cross multiplying, but it's using least common denominator to get there. Cross multiplying is multiplying both sides by the least common denominator. We simplify out the like term, multiply what we get left. And I have no issue with cross multiply, but it only works if I have one fraction set equal to one fraction, which is fine for problems like this one here, the last one, or these here. But when we start getting more than one fraction, cross multiplying does not work. I don't like having a method that works in one case, and we have to learn a new method for when we get outside of that. Because here, least common denominator will still work. But before we solve, let's go on and find our restrictions. And the nice thing about the restrictions is if one of these two values shows up as a solution, we can immediately throw it out because it does not work. Now, to find the restriction for x plus 2, we would subtract 2 from both sides, telling us that if x is equal to negative 2, we would have a division of 0. It doesn't work because negative 2 plus 2 equals 0. We'll do a similar thing with our 3x plus 2. We would subtract 2 first, telling us that 3x is equal to negative 2. We would then divide both sides by 3, telling us that if x is equal to negative 2/3, we could have a division of 0. That does not work. Now, as we look at solving this here, again, we want to make sure the denominators are as simplified as possible. And they are. There's nothing that we can factor out, no way that we can rewrite or change 3x plus 2. No greatest common factor, does not factor. Same with x plus 2. What's one thing we're going to multiply both sides by? X plus 2. Because that will simplify the fraction denominator on the left-hand side. What else do we need to multiply by? Well, our only other expression on the bottom, which is 3x plus 2. Because if we multiply through by this least common denominator, the left-hand side is going to become 2 times 3x plus 2 times x plus 2 over x plus 2. And the right side is going to be 10 times x plus 2 times 3x plus 2 over 3x plus 2. And now that we have this set up, we know that on the left-hand side, the x plus 2 and x plus 2 will cancel. On the right-hand side, the 3x plus 2 and 3x plus 2 would cancel. Telling us that we have 2 times 3x plus 2 is equal to 10 times x plus 2. So we use that least common denominator. We multiply through to get those fractions to simplify, to reduce down. And we're going to solve for x. So we can multiply by 2 on the left. 2 times 3x is going to give us 6x. 2 times 2 is going to give us plus 4. On the right-hand side, 10 times x is going to be 10x. 10 times 2 is 20. Now we can solve for x. We just need to get x by itself. Because there are no quadratics, higher degree polynomials. We're just going to get x by itself. There's 4 main steps we can do first. We could subtract 6x from both sides first. We could subtract 4, subtract 10x, or subtract 20. However, if we subtract 6x from both sides, 6x minus 6x cancels, leaving us with 4 on the left-hand side. 10x minus 6x would give us positive 4x. Then to get x by itself, we can subtract 20 from both sides, leaving 4x on the right-hand side. And 4 minus 20 would be negative 16. And last but not least, we can divide both sides by 4. 4x divided by 4 is going to be x. Negative 16 divided by 4 is negative 4. And since that's not one of our restrictions, we know that that will be our answer. Negative 4. And if it did ask us to check it, we could just plug it back in, 2 over negative 4 plus 2. And see if that is indeed equal to 10 over 3 times negative 4 plus 2. Now, in the first problem, we just kind of simplified it by hand. For this one here, I'm going to plug it into the calculator. So we have it'd be 2 over negative 4 plus 2. And we get negative 1. Our other side, we have 10 over 3 times x, so 3 times negative 4, plus 2 is also negative 1, telling us that negative 1 is indeed equal to negative 1. Both sides are the same value, telling us that that is the solution. Questions on this here? Are you ready for the next one? So we can look at our restrictions first to see what values of x we cannot have. Does anybody have a guess at what those values of x are going to be? Well, the two places we can't have there be a 0 is in the place where x minus 7 is, and the 5x. Well, the x minus 7, if we wanted to solve this, we would add 7, telling us that if x is equal to 7, the denominator would be 0. It'd be a restriction. We can't have x be 7. 5 times x equals 0. Divide both sides by 5, really telling us x cannot be 0. So if we get positive 7 or 0, those are restrictions. We cannot have them. What are we going to need to multiply through by to get these fractions to simplify? 5x and x minus 7. Now, on the last few, and this one here, I'm going to start it off the same way. We're going to be multiplying our 5x times x minus 7 and our 3. So we're saying 3 times 5x times x minus 7, and it's over 5x. On the right-hand side, we have 2 times our 5x times our x minus 7 over x minus 7. And as up to this point so far, the 5x and 5x will cancel. And on the right-hand side, our x minus 7 and x minus 7 will cancel. Now, is there anything saying we couldn't have just gone here and here, here and here at the start? No. I've been writing it like this so that we see why this works, why we can cancel those out, and that we're left with 3 times x minus 7 is equal to 2 times 5x, or just 10x. Now we just need to solve for the value of x. 3 times x is 3x. 3 times negative 7 would be negative 21. Then our next step would be to add 21 to both sides, yes? No, I wouldn't add 21 to both sides. Is it wrong to add 21 to both sides? No. Is it adding extra steps? Yeah. Because the constant terms are already by themselves, there's not a whole lot of reason to move it. Not wrong too, just not necessary. Because if we subtract 3 from both sides, we get that negative 21 is equal to 7x. Divide both sides by 7, telling us x is equal to negative 3. Questions on this here? Really, the big thing with solving is knowing to multiply through by that least common denominator to get the terms to cancel. So looking at this one here, restrictions. What can x not be? 3 and negative 3, because x plus 3, negative 3 plus 3 would be 0. And x minus 3, 3 minus 3 would be 0. But it also tells us what we need to multiply everything by. We need to multiply each of the expressions by x plus 3 and x minus 3. Because that's the least common denominator, our common factors on bottom. Now, I haven't mentioned it up to this point, but since the denominators don't factor, we don't have to factor at the start. But if they do factor, we need to factor them first. But this here, the x plus 3 and x plus 3 would cancel, leaving me with negative 4 times x minus 3. On the right-hand side, the x minus 3 and x minus 3 would cancel, leaving us with 5 times x plus 3. Now we need to solve. We'll distribute the negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 3. Negative, negative makes a positive. 4 times 3 is. On the other side, we'll distribute the 5. 5 times x is 5x. 5 times 3 is plus 15. Doesn't matter where we go first. I'm going to add 4x to both sides. Because negative 4x plus 4x is 0, leaving us with 12. 5x plus 4x is 9x. Subtract 15 from both sides, telling us that 9x is equal to negative 3. And last but not least, we would divide by 9, telling us x is equal to negative 1/3. Not a restriction, so that still works. Negative 1 divided by 3 store x. So what I did there was just plugged in and told the computer, or told the calculator, that x is negative 1/3. And by doing that, I can just type in negative 4 over x plus 3 because it's assigned negative 1/3 is the value of x. So we can do 5 over We see that both sides are negative 3/2. That is the correct answer. Questions on this here? We'll pick this up tomorrow. Well,